Okay, so now we go back because we didn't start at the first part of chapter 4. We started with the factoring, right? Factoring, then solving equations, factoring expressions, solving equations, and now we're going to go back to the graphs of quadratic functions. And it's actually in two sections. The first section, we do it all by transformations. The same way we did the absolute value of v, and we moved it all around by adding and subtracting numbers and putting minus signs in there. That's what we do now with the graph of a quadratic function. And then in the next class, we do it without transformations. Okay. But these are the same objectives that we had when we did the absolute value graph. It's just instead of saying absolute value, now it says quadratic. Okay, so we started here. Basically, we factored expressions. We solved equations. Now we're going to be graphing equations like this, right? That's a quadratic function because it's got a y and it's got an x. And it's written in a standard form as it is. Today we're going to learn about a different form, which is called the vertex form. Now first, if we compare the two graphs, if you compare the graph of absolute value, the v that we already know, to the y equals x squared, which is the parent function for quadratics, you can see here's the v that we know, right? And then the other graph is not a v. What does it look like? Yeah, it's more like a u. In what world is that a w? Okay, so this typical shape of a quadratic function is a u, and that u is called a parabola. Okay, so I think amongst all the slides that I've got, there'll be some repeating of some of this stuff, but the parabola, like the absolute value v, is symmetric. Curtis? Okay. It's symmetric with respect to the middle, right? It looks the same on the left as it does on the right. Remember the point of the v, we gave it a name. It was called vertex. Well, to say the same thing at the base of the u, whatever that point is at the very bottom is also called a vertex. And like I said, this is probably going to repeat itself a little bit, but the line that goes right through the vertex, like that, is a line of symmetry. Like in geometry terms, a line of symmetry was a line that divided the shape into two halves that were mirror images of each other. Right? So the left side of that u is the same as the right side. Notice that if you go up to y equals 4, then on the right, you go 2 to the right, there's the graph. 2 to the left, there's the graph. Yeah.
Are you saying the vertex for the v or the u?
It's the same place. Right?
It's also the vertex.
Yes. Both of them are called vertex. Right. And that line, that line of symmetry, when it comes to parabolas, has got a specific name. It's called the axis of symmetry. But this is the graphic in the book. Again, we are using this f of x equals x squared for our graphing today as the parent function. Right? All the others, Mark, you need to stop that. Okay? All the others are in the same family, but as we add and subtract numbers inside and outside the function, things like that, there would be variations of this parent function. All right. Now, the parent function, f of x equals x squared, the vertex definitely at the origin. Right? It's right at 0, 0. And the axis of symmetry, again, is a vertical line that goes right through the origin. So because you name a vertical line with x equals a number, since it's going through 0, 0, that's x equals 0. That's the line. And let's see. I think that's, if you did a little table of values for that, just to see what it is. We know we've got 0, 0. That's the vertex right in the middle. At -1 and 1, when you plug in -1 or 1, what do you get for the value of the function? 1, right? So that's a 1 and a 1. Notice that on the graph, then, at 1, 1, and -1, 1. That's the typical for the parent function that looks like that. And we would expect at -2 and 2 that it's going up to 2, 4, -2, 4, right? Because that's 2 and -2 squared. Right, so you can see it goes 1 to 4, 1 to 4. Okay, so there's two forms of the quadratic function. And the first one is no parentheses. It's the one we've used, right, for all of the solving equations. We always started with the standard form equals 0. Ax squared plus bx plus c. Okay. In that form, what we know from the a, we know that if the a is positive, that it opens up. If the a is negative, it opens down. Right? The parabola would be upside down. The plus c is the y-intercept. The constant term is always the y-intercept of any polynomial. The constant term is the y-intercept. Because how do you find the y-intercept? You substitute x as 0, right? Well, if you substitute x as 0, all the terms except for the constant term are 0. So that's why the value of the function is whatever that number is. Right, so when you've got it in the standard form, you know about the graph right away, those two things. Does it open up or down? What's the y-intercept? Right. The one that we're doing today is called vertex form. Right? The vertex form looks like this. F of x equals a parentheses x minus h squared plus k. Now, in that form, the HK is the coordinates of the vertex. So you could tell by looking at it, if you see it in that form, you know where the vertex is already. You don't know the vertex up here, right? But you know the vertex down here. And then the A, which is in front of this set of parentheses, it's the same A as that. So you learn exactly the same thing from the A here as you do here. If that A is positive, it opens up. If that A is negative, it opens down. So most of what we do today is just kind of use this form to graph and to see it as, like we did with the absolute value, as transformations of a parent function. Just scoot it left, right, up, down, flip, multiply by a constant. So I'm going to go through one at a time and play with the A and the H and the K to show what happens to the graph. Right? So in this one, I'm graphing on the same background. I've got the y equals x squared and y equals 2x squared. So it's like having that A be a 2. What happens to the graph? Now, in the calculator, and you could do this for yourself on the calculator if you wanted to, on the first line, I put the x squared. On the next line, I put the 2x squared, and I made the line fat by going into the margin there and hitting enter so that it turned the line fat. So you could tell the difference between the two, right? This one here is just the regular old x squared. The fat line there is y equals 2x squared. So what does it look like it did to the graph? Even looking at the table of values, you could notice these values, right? At -3, for y equals x squared, it's 9, but for y equals 2x squared, it's 18. Right? At x equals -2, for y equals x squared, it's 4, but for y equals 2x squared, it's 8. What's it doing to all the y values? It's doubling them. What do you think would happen, right? By multiplying by 2, it makes all the y's double, which makes it look like the graph is going up faster, right? It's going up faster as you move away from x equals 0, to the right and to the left. Right, so we see that's the effect of multiplying by a number bigger than 1. It makes it go up faster. What do you think will be the effect if I multiply it by a number less than 1? It does the opposite. Right, here's the y equals x squared and y equals 1/2 x squared. Notice all the y values. They go from 5 to 5 halves, from 4 to 2, from 1 to 1/2. Right? They're all half of what they were for y equals x squared. And so what does it look like the graph is doing here? Let me remind myself what's on the next page. Okay. This is called a stretch. When it goes up faster, it's clearly called a stretch. Nobody debates what word to call it when it's a stretch. Well, I should change that a little bit. Maybe they do debate it. When it's multiplying by a number less than 1, some books that we have call that a shrink, right? This book calls it a compression. It's a vertical compression by a factor of 1/2 when you do that. I heard next Wednesday we take our test, and then next Friday we take the benchmark. And we don't write the benchmark. It's written downtown. I heard that they use the term horizontal compression to describe that. So horizontal compression would mean it's squeezing this thing horizontally. I've never heard that before, and honestly, I think they're confusing themselves, because this is the first year that our book actually didn't call that a shrink. They call it a vertical compression, but there's nothing in there that says horizontal compression. So maybe you'll see when you take the benchmark, a horizontal compression. I think that's creative test writing by downtown. So basically this A, the A is either a vertical stretch or it's a vertical compression. That's what we usually call it. It also tells us, based on the sign, whether or not it's opening up or down, right? If it's A is greater than 0, you'll call that it's opening up. If A is less than 0, it's opening down. Good. I mean, I think we did that with our absolute values. This class we did. Okay. Okay, now we got to figure out what happens when we add or subtract inside the parentheses, right? Inside what's being squared. It's the same thing that happened when we did it to the absolute value, right? If you're adding or subtracting numbers inside the parentheses, inside the function, that's a horizontal shift, meaning left or right. Okay, minus means to the right, plus means to the left. Remember, that may seem counterintuitive to you, but that's the way it works. Right? I mean, notice I compared on this background. X squared is still the thin line, and then the fat line is x minus 2 squared. So I would expect, based on what I said there, that the minus 2 inside means 2 to the right. And what did it do to the graph? 2 to the right. Right. So if you're not sure which way it is, put something like that as just a test case in your calculator and see what it gives you. Now, in this problem, let's say this right there, right? Y equals x minus 2 squared. I'll use the f of x just because that's the same thing. Tell me what is the value of h? Okay, remember, the minus is in the formula. So the h is actually positive 2, which is why the vertex is at 2, 0, right? So it gets confusing because of the minus which is in the formula there. But just think as a transformation, minus means right, plus means left. Okay, now what happens if we add or subtract after the function? Okay, that's a vertical shift, up or down. In this case, nothing counterintuitive to it. Plus means up, minus means down. Right? As an example, I did x squared and x squared plus 3. You know, what does it look like happened to the graph when I did the plus 3? Up 3, which is what you expect. You know, look at the y values. 9 to 12, 4 to 7, 1 to 4, 0 to 3. Everything just went up by 3. Sketch a graph. I mean, I hope these are somewhat familiar because we did them with absolute value, right? And we're going to do them with other functions after this. We don't want to keep relearning this stuff like it's new, right? It's not new. Okay, now let's see what happens to the graph if we put a minus in front of it. I mean, we did that with the absolute value too. What did it do to the absolute value? It flipped it. Okay, the same thing. Here's my x squared is still the thin line, and then negative x squared is the fat line, right? Here's x squared, here's negative x squared. It flipped it across the x-axis. You know, sometimes called reflection in the x-axis. But if you just say flip across the x-axis, that's fine. Right? Notice what happened to all the y values, right? They go from 9 to negative 9, 4 to negative 4, 1 to negative 1. It just flips all the y's. Okay, are there any other possible things we can do to this parent function? Nothing. Okay, so now here's the graph. And some of this stuff, this analyzing graphs, it's where it gets kind of, I know it gets confusing for you, but we do this with all the functions, and this is like the start of it. I mean, there's not a whole lot of point of analyzing linear graphs. There's not that much going on in a linear graph. But now it starts to become interesting, right? Now, notice we have two parabolas. We have the parabola where the a is greater than 0, which means the parabola opens up, right? We have the parabola where a is less than 0, which means the parabola opens down, right? In either case, the place where the graph changes direction, the very bottom or the very top of the graph, is the vertex. And the vertex has the coordinates of h, comma, k. Right. Now, the axis of symmetry is a vertical line that goes through the vertex in both of these, right? But if it goes through the vertex, then it must have an equation of x equals the x coordinate, the h. So x equals h is always the equation for the axis of symmetry, right? If the vertex is at hk, axis of symmetry of x equals h. Some of this will get emphasized again in the next section. If the parabola opens up, then that point on the graph is considered the minimum of the graph. It's the least y value on the graph, right? The y values, if I start up here, are going down, down, down. The graph is what we call decreasing. It's decreasing, 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 decreasing until it gets to just that point, and then it's increasing, which makes that point the minimum, the lowest value on the graph. So decreasing, increasing. right? If the parabola opens down, then the vertex is the maximum point on the graph, right? It's the highest point on the graph. The function is increasing from the left until it gets to the vertex, and then it's decreasing. My bet is that you'll see some question, maybe just one, on the benchmark that says something about increasing or decreasing. I'm not sure. It's not really something that usually gets talked about in this chapter. Next chapter, that definitely does with polynomials that have more interesting graphs. But they told us about a week ago or something that they would have it in there. So I'm just bringing it up so it's not totally foreign to you. Okay, so most of these things I'm going to do now as examples are taken from the homework sections. So I'm doing like an even number just so you know what you're supposed to do with the odd numbers that you get. And the directions are just copied from their directions. There should be any confusion about what you're supposed to be doing here. Okay, so the first kind of problem you do, it says graph the function, describe how it was translated from the parent function f of x equals x squared. So describe what's going on in this function. The plus 3 inside means left 3. That's all you have to do. Left 3. Just describe what it is that's going on. Now, if it went left 3, I'm going to make this a little bit of a fatter line. That means that the vertex of this thing is at -3. Right? And because it's got a 1 in front, it's not being stretched, it's not being compressed at all. You know, we would expect that from there it goes over 1 and up 1. It goes over 2 and up 4. Right? It goes left 1 and up 1. It goes left 2 and up 4. Just the same shape that it had when it was at the origin. So we can sketch that in, look something like this, if I can see it. You know, I'm being kind of careful, and I got the grid in the background to make sure that it is going up, over 1, up 1, right? Over 2, up 4, left 1, up 1, left 2, up 4. That gives it the right shape, right? And it's been shifted 3 to the left. Good? Easy? Okay. Okay, the next set of problems say, identify the vertex, the axis of symmetry, the maximum or minimum value, and the domain and the range. Okay, that'll be a new one for us, but that is another part of these that we should understand. Okay, it doesn't even say to graph, but it might help me just to look at a graph. When in doubt, draw a picture. Yeah, draw a picture. Sometimes it could help. Remember, we're comparing this function right here to this function. Y equals a times x minus h squared plus k. So looking at that and understanding that h comma k is the vertex, what is the vertex of this parabola? Okay, is it a positive or negative for the h? It's positive because the minus is part of the formula, right? And then that's positive because that one, it's not a counter sense, right? So we're going to say that hk, the vertex, is 125, 125. Okay, then what would be the equation for the axis of symmetry? Yeah, that one's not even a good problem because they're both the same number, right? So you could be putting it through the y value and I wouldn't even know. So x equals 125, right? Because of that. What is in this case, is it going to be what do they mean by the maximum or the minimum? But in this case, what point is that? It's the vertex, right? Always when they ask you for a maximum or a minimum, they're just asking you for the vertex. And you already found the vertex. Your only decision is it a maximum or is it a minimum? Well, how would you know? Based on whether it opens up or down. Which direction does this one open? It's up because it's positive, so that vertex is what? It's a minimum, right? The minimum point on the graph is 125, 125. And then the last thing, and I'm going to sketch a little graph here. Right. We know that we have a parabola that has a vertex at 125, 125, and it opens up like that. And we did a little bit of domain, right? But most everything we did with domain, you had like a finite set of points and you looked at those sets of points. But this is a graph. And most of the questions you actually get about domain will not be a finite set of points. It'll be more like this. And for domain, because you see these arrows going infinitely to the left and infinitely to the right, the x values that would be represented, if I could write down all of these points, would go from negative infinity to positive infinity. Or another way of saying it is all real numbers. So domain, again, I know this is kind of new, but you would say the domain, because this graph goes forever to the left and forever to the right, the domain is all real numbers. Now, what do we usually mean by the range? The y values, right? Do the y values look like they go forever up and forever down? Which direction are they limited? Say it, John? I can't hear you. Still don't hear you. Above zero? Do you say this graph is going down to y equals 0? Well, what is that point? It's 125. So how would you say the range? Okay. This is how you would say it. Range is y is greater than or equal to 125. Right? It starts there and it goes up from there, and it does go up forever, right? So it goes from 125 to infinity. Okay, graph the function, identify the axis of symmetry. So in this case, we're just sketching, right? We're trying to do transformations, not just put it in the calculator and copy a graph, or make a table of values and just plot the points and then mindlessly connect them. We're trying to like to understand a little bit about the graph. So let's see, as much as I can. What is the vertex of this? Right? Say again? -7, -8. Remember, the formula has an x minus h. So if that's a +7, that's an x minus -7 is really what it is. So the hk is -7, -8. Which direction does it open? It opens down, right? So if I go to the vertex, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8. There's the vertex. And it opens down, okay? But should I go the 1 over and 1 up? No. Because what's making that different? That 3 right there means, you know, when I go over 1, how far should I go down? I should go down 3, right? The next point is going to be there. And what about when I go over 2? I'm going to have to go down 6, right? Actually, that's not right, is it? If I go over 2, then that'll be 2 squared is 4, -3. Now I'm messing it up. It would have been 4. It's going to be 3 times 4 is 12. It's actually way the heck down here. The same thing to the other side. It'll become there and somewhere down there. So if I draw the graph it's going to look something like that. And again, somebody said it. Yeah. I mean, here's the thing you keep in mind, right? You might get confused. When we said stretch or compression, we said when the A is less than 1, this is going to be a compression, right? But you want to consider this minus sign as having its own effect, right? Because -3 is less than 1, but that's still a stretch, right? So this is the flip, right? The 3 by itself without a minus sign on is still a stretch. It's stretching it down, right? The +7 is a left, and the -8 is a down. Okay, now, where do I draw the axis of symmetry? Is it like this? Vertical line, right? So it's going to go like this. Okay, so it says identify the axis of symmetry. When you say identify, what's the equation? X equals -7. Remember, vertical lines are named as X equals because what is the X coordinate of every point on that line? -7, -7, -7, right? That describes the line. Every point that has an X coordinate of -7, that's a vertical line. Okay, now we got one where they give us the graph and they say write the equation. So let's see, what things can we see from the graph? So the vertex is -1, -1, -3, right? So the HK is -1, -3. That's going to tell us this part here. And it's opening up, right? So we know we want our A to be positive, right? So this will be f of x equals, and at least this part, what goes inside the parentheses? X plus 1, right? X plus 1 squared. And what goes after the parentheses? -3. So the only question now is, do we need to be multiplying this thing by a number other than 1? And just notice the shape here. Is it going over 1, up 1? How far did it go? When I went to the right 1, how far up did it go? It actually went up 2, right? Look at the other side. Left 1, up 2. So it's actually, there's a 2 in front of there. It's being multiplied by 2. So I think you have 2 to do like that. And I think I got one more. Okay, and this one, there's not a homework problem like this, but I just was going to, let's go through and just say what are all the things we see in this. The first one, the -2 tells you 2 things, right? Say again? It's a stretch by a factor of 2, but the minus means it's opening down. So it's still a vertical stretch. It's a vertical stretch down. How about the -1? Right 1. What kind of a vertical shift is there? None. You don't see a number out there? That means it's +0. How about this one here? It opens down. It's a stretch. Left 1. Up 1. Okay, what about that one? Opens up. Stretch. Right 2. Up 3. Okay, how about this one? It's a flip. Is it being stretched? Why? Right? Because it's a 1, right? It has to be a number bigger than 1 or less than 1 to change the shape of the graph. How about the +4 inside? Left 4, up 5. Okay, what about this -0.25? Right? It's flipped and it's a compression, right? Because that's a number less than 1. 0.25 is 1/4, so it's going to go up 1/4 as fast as a normal parabola. And then, does it have a horizontal shift? No, I mean, when you just see an x squared like that, that means x minus 0 squared. So that's no shift. And plus 3 means up 3. And the last one, compression. Compression, is it opening up or down? Up. Minus 12 means right 12, minus 3. Okay, here's a quiz question for you. On number 43, what is the equation of the axis of symmetry? X equals negative 4, right? Because the h is negative 4. It's x equals negative 4. Okay, what about on number 44? What is the equation for the axis of symmetry?
0.
X equals 0. So that's what we did. That's homework.